Hello, my name is Aiden Konig, and today I am here with you to talk about the effects of regional biodiversity of honey. Now you may think, out of all the projects in the whole wide world, why did I choose this one? So basically, my family and I have been producing honey for a few years now, and we've been very interested in the process, how bees make it, how it's sold, all of it. So I wondered, once we had our raw honey, is it any different from any other raw honeys around the country? For example, since we live in the Midwest, is it any different from a southeastern honey or a northwestern honey? So this is what got me curious about my project. So to start it all off, I decided to do some research on how bees make honey. And it's pretty complicated, but I'll try to sum it up. Bees pretty much suck up nectar from a flower into a sac called a crop. And from there, in the crop, the nectar breaks down into simple sugars. And those simple sugars are then passed to an inside bee. And the inside bee is the one that works on the inside of the hive. And the inside bee passes it around and around until it finds a place to be put in one of the cells. And then the cells are capped off, and at this point, it has lost some of its original moisture, and then while it is in the cells, it just gets hot in the hive from the bees' body heat and from their wings flapping, and it ferments into honey, which is what we love. And so now that I knew how bees did the thing, make the honey, I had to look at different pollinators from around the U.S. because no area is the same as another area. For example, maybe in the Midwest here, it would be a common pollinator that is alfalfa. But in the Southeast, does alfalfa even grow? I didn't know yet. So I decided to do some research on the different areas of the U.S. to find their most common pollinators, and it was pretty promising that no area has the exact same pollinators as another area, which is perfect for my research because now I was going to compare those pollinators with a Brix refractometer. And so all the honeys are going to be put on the prism, the little blue part near the front. And it's going to be closed, and then you can look through the eye or to see your numbers. So your sugar content percent, your water content percent, and that's what I was going to use to compare those two data. It's a very, very useful tool, and I really loved using it. So the purpose of my project all summed up. The purpose of my project is to test different honeys from different areas around the U.S. for color, sugar, taste, pollen, and water levels. So pretty much 5 factors that I'm going to taste with 6 different honeys. And so my hypothesis, I hypothesize that there's going to be differences in color, taste, and sugar content. However, I also predict that we may be able to see pollen grains through a microscope and determine which flowers were used to make every type of honey so that we can compare the taste and the sugar content and the water content all up, and then we can see if there's a pattern or a correlation. So my procedures. So pretty much what I'm going to do for color is I am going to take the honey and use a standardized chart right here. I'm just going to decide which one it looks most like. And that's pretty simple. I would like to do a more in-depth one later, but for now, this is my plan. For the taste, I'm simply going to be tasting it myself, and then it will be graphed 1 through 6. For the sugar content, we will be using the Brixometer, and for the water content is the same. So the procedures for looking at through the microscope are pretty usual. Put the honey under the microscope, and we'll try to see if we can find any pollen grains. If we can find any pollen grains, then we will use Google to try to find which types of pollen those pollen grains actually are from to really solidify whether or not it makes a difference which pollen is used in certain types of honey. So here are some pictures of me using the Brixometer. It's a very fun to was a very engaging process. I really loved doing it because I was always curious to see the results. Like, was this honey going to be way low in sugar content but high in water content, and this honey way low in water content but high in sugar content? It was just so fun to use. And here are some more pictures of me using it. And in the bottom right, there's my rankings. This was a very, very fun process. I really enjoyed it. So here are the results for the taste test, 1 through 6. Now, number 5, Prairie Smoke Hive, is actually our honey that we made, which is interesting to me where it landed on my taste test. But for the results on the color test, we just simply matched it up. Really, most of them were the same. As you can see, 4 of them were 400, and we couldn't see too much correlation between the taste and the color, as you can see here. But for the sugar test, we began to see a little bit of correlation. As you can see, Prairie Smoke is the lowest one. However, it wasn't lowest on the taste test, but it was close. And Rocky Mountain being the highest in sugar content and also the highest on the taste test. So that's very interesting, and obviously, if I were rating it on sweetness, which I was, that would make sense. But then the water content kind of messed us up. As you can see, at first, it looks great. Prairie Smoke Hive has an 18% water, and it only had an 80% sugar. Rocky Mountain had a 15% water, and it had 83.5% sugar. So those numbers were looking great, and we were beginning to see a pattern. However, it really didn't solidify itself with the other 4 numbers as we looked into it, which was disappointing. And yeah, so the results for our looking at pollen grains through the microscope, we could see some, but we couldn't see them. We didn't have a high enough power microscope to identify which types of pollen they were, what flowers they came from. So I'm going to be working with an entomologist at ISU this summer to better decide what types of pollen those are. And yeah, this is my conclusion. I thought that there were slight differences in the Brix readings, for example, water to sugar, and unfortunately, I just didn't have enough time or data to validate my hypothesis. And I really wish I could have made the color scale more accurate. So, for example, using a group, like a group of 5 people, and they can all test the honeys and they can rank them, and then I average that out. And next time, I'm going to use a spectrophotometer to test how much light will pass through the honey so we get a really, really accurate tell on the color. And the taste was simply a preference as well. As I said, I did get out of the taste test, though, is that it's not only sugar that can make things different. Possibly the pollinators, and I'm pretty sure it is the pollinators, because, for example, if a southeastern honey was raised on a pepper plant, it seemed to taste a little spicy, which was interesting. And I was very disappointed about that we couldn't see the pollen, but I am excited to go to Iowa State University and work with an entomologist so that we can tell whether or not the biodiversity of a flower controls the taste of the honey, the sugar content, and all that jazz. So here's my bibliography, and thank you for listening, and I hope to speak with you about my project again.